How do you see mass spec technology evolving?
I'll put on my prediction hat and say that if I look at chromatography, mass spectrometry, the big question I have is what's AI going to bring to the table? Because I can think of some very obvious things. Like, I teach people all day long how to look at peaks. You look for tall, skinny, symmetrical peaks. You don't want shoulders. You don't want tails. A computer can do that and maybe tell me when I have a problem before I know I have a problem. We already see some pretty heavy computer stuff in the mass spec part of the world. I think it'll be interesting to see what AI brings. In terms of technology, you're always going to see everyone wants lower sensitivity, lower detection limits. Moore's law is in the computer world. In our world, every generation of mass spec is 10 times more sensitive than the previous generation. We see a huge gain every generation of instrumentation. And most of the gains, from what I can tell, are really cool electronic stuff, like figuring out a way. I always describe a mass spec as we're creating a beam of ions. So it's like a flashlight. And this beam, I'm shooting across the mass spec, but it's a beam of ions. The beam is going to start to spread out, start to diverge. And I'm going to lose sensitivity because I'm not going to have as many ions making it to the detector. A lot of what we see in the newer mass specs is I'll call collimating lenses. Lenses that are electronic magnetic that are refocusing the beam. The tighter the beam, the more ions we get to the detector. The electronics are going to continue to get better, so we're going to see sensitivity get better. I always question, do we need more sensitivity? In a lot of regulatory environments, whether you're doing environmental stuff or pesticides in food, pesticides in cannabis, it seems the regulators just take the easy way out and they choose the regulatory limit to be the lowest detection limit of any instrument. If someone comes out with an instrument that's 10 times more sensitive, all of a sudden that becomes the new law. And that to me says, well, they're not setting the law for real reasons. They're setting it for just based on the instrumentation is. So it is sort of a little dangerous part of what we do is we're going to make them more and more sensitive. The question on the other end is this value, does it mean anything? If I can find 1 per quadrillion of uranium in someone's blood, does that mean they're radioactive? And the answer is no. The challenge as we get to more and more sensitive instruments. And then I also take another big step back and I say, I interact with a lot of people in big companies, big industries, and I see a lot of people in the industry are doing things the way they did in 1988. It seemed like everyone sort of came to this level of technology and stopped adapting new stuff. So just learning the fundamentals, just learning things like pulsed injections, been out there for 20 years and no one is using it. No one knows about it. So to me, just get a feel for what's already out there, understand what's there and how it works. And even little improvements are big for industry because, like I said, it's amazing how many times you'll tell them something that came out 20 years ago and they'll run out and be like, oh my gosh, this has changed our lives. So understanding the fundamentals of GC, mass spec, and LC, I think it'll take you a long way into seeing what's going to happen next.